This first example, we're given the velocity v at t, which is in meters per second, of a skydiver falling near the Earth's surface. And that's the equation right here. So v at t is equal to all of this on the right-hand side. It's definitely an exponential function, and we have our friend e in there, which is just a constant. Time is going to be measured in seconds. A says, what is the initial velocity of the skydiver? Round to the nearest whole number. All right, for this one, t is going to be 0. The initial velocity is at time 0. So we can write that over here. T will be 0, and if you want, you can put the units there. 0 seconds. And we're asked to find the initial velocity. Remember that the velocity is v at t. So we have v at 0 seconds is equal to 48 times 1 minus e to the negative 0.16 times t, which is 0. Some of these you have to do in your calculator. However, I think this one's going to be easier to do by hand, and what I'm seeing here in advance is we're going to have 0 times this rate up here, which is 0. So if we simplify this by hand, this is 1 minus e and then to the 0 power. And again, we want to follow our order of operations here. We want to look inside the parentheses first. These are all numbers. Yes, I know that that is a letter, but e stands for a specific value. It's a number. So these are all numbers. We're just going to go ahead and evaluate it. And then we're going to do the exponent part here. So this is 48 times 1 minus, well, anything to the 0 power is 1. We continue this on the right-hand side. We have 48 times 1 minus 1, or 0, and that's 0. And we could write meters per second here. So the answer is 0. Now, when you're doing these word problems, or modeling problems or real life problems, you want to check to make sure that your answer is reasonable. If we got 8 million meters per second here, well, that would be just ridiculous. So this answer, though, is very reasonable at 0 seconds. So at the start of the dive, you wouldn't be going any speed. If you just, like at the split second you just left the airplane or whatever you're jumping out of. So that does make sense. The next part B here says, what is the skydiver's velocity after 5 seconds, and round to the nearest whole number. This one's going to be a little bit trickier to find the answer to, but I don't think we're going to be able to do it by hand. We're just going to go ahead and type it in the calculator. So t for this one is 5 seconds, and v at t is equal to 48 times 1 minus e to the negative 0.61 times t, which is 5, and that's all inside parentheses. So with the last one up here, we had 0. We could deal with e to the 0 power, it's 1, and then we could just simplify it by hand. This one, though, we're not going to be able to do that. So if nothing simplifies easy right away, I would highly recommend that you just go ahead and type this whole thing in. So if we take a look at our TI-84, we're gonna have to do 48. So that would be 48 and then parentheses 1 minus e. I'm going to raise that, and I'll just use parentheses. I don't think you have to when you have this program that adds the superscript position, but it's always a good idea to use those. We want to group this exponent together here. If you don't, then the calculator will evaluate this first, and then the next one, it will multiply that whole value by 5. We don't want it to do that. We want it to first multiply the negative 0.16 times 5, and we're going to close the parentheses there, and we'll see what happens in this case. So you can see that if we enter this in correctly, we have 26.43, and then the decimal keeps on going, and this is round to the nearest whole number. So this is going to be just about, and we could use approximate symbol if we wanted to, 26 meters per second. Is that reasonable? Well, it kind of is reasonable. I mean, 26 meters per second is a believable speed after you've been falling, well, through the sky after 5 seconds. That would seem pretty reasonable to me.